It turns out that if we think about addition on the integers, there are three properties it has that especially stand out, and they're encapsulated in this definition of a group. So a group is a set S with a binary operation where the binary operation has special properties. It's associative, it has an identity element with respect to the binary operation, and every element has an inverse with respect to the binary operation. So this is a very vague definition, and we're going to make it a little more explicit in this video in terms of addition, and then we'll talk about multiplication a little bit later after you've had a chance to think about it some. So if we want to think about this definition in terms of the operation being addition, then our definition, we can be a little bit more explicit. So S is a group under addition if, and now we're going to actually translate this into four properties. So I'm going to call one of them 0. The binary operation bit is what we need to say first. And another way to say that we'll use coming up is that S is closed under addition, okay? And that closed under addition, that's the binary operation piece. And we'll see some examples of that so that it'll become clearer as we go, okay? So that's property 0, and it's all encapsulated in that binary operation above. All right, it's supposed to be associative. So if we're talking about addition, the associative property for addition says for every A and B and C in S, the associative property is that A plus B plus C would be the same as A plus B plus C, okay? So I need to be able to do that addition, do whichever pair I want first in terms of the addition, okay? Next has an identity element with respect to the binary operation. That means there is an element in S which we call 0 such that for every A in S, A plus 0 is the same as 0 plus A, which is A. Okay, so an identity element is something that if you use it as one of the ordered pair, it doesn't change anything. Okay, so A plus 0 is A, 0 plus A is A. The last piece is that every element has an inverse with respect to the binary operation. So this is for every A in S, there is a B in S, so that A plus B equals that identity 0. So the inverse is the thing that kind of undoes the binary operation. And note for this one, we usually write B is minus A when we're talking about addition. And we'll talk more about that later because there's some subtleties involved in writing that B equals minus A. So we'll explore that a little bit later on. All right, so our group definition up at the top becomes this definition if we're talking about addition. So it has to be closed under addition. It has to be associative under addition. It has to have this additive identity, which is also known as 0. And it has to have inverses of every element, which under addition, this means sort of negatives of every element. All right, so we're going to try some examples. This set of integers is a group under addition, okay? Closed under addition, property 0 says the sum of two integers is an integer. So this is the binary operation piece, that if I take a pair of things and I do this operation, I get back the same kind of thing. Okay, so that's definitely true for the integers. Part 1 was the associativity, and that's true for A and B and C that are integers. A plus B plus C is A plus B plus C. This is a fact about the integers that we know. Okay. Part 2, there has to be an identity element under addition, and 0 is that element in the integers. A plus 0 is 0 plus A is A for any integer A. That's definitely true. And then part 3, there has to be an additive inverse. And for the integers, for any A in Z, we know that minus A is also an integer. And we know that A plus minus A is 0. Okay. So the properties hold for the integers. Let's try one where these, at least some of these properties, do not hold. So let's do a quick non-example. Let's take the set of all odd integers. So if we take the set of all odd integers, if I take 2 odd integers, if A and B are odd integers, is A plus B an odd integer? And the answer to that is no. So for example, 1 plus 3 is 4, which is not odd. Okay, so what that is saying is that the odd integers as a set is not closed under addition. Okay, if you add 2 odd integers, you do not maintain your status as an odd integer. You're now even, and that's trouble. So that's it's not a binary operation, or it's not closed under addition bit. All right, so in the next video, we'll see a couple more examples of sets that are groups under addition, and we'll verify those groups under addition properties.